11 is asking us to use Heron's formula, or actually explain how to use it. And rather than having you explain how to use it, I'm just going to have you find the area. This is what they're asking you to do anyway. So remember that Heron's formula, you have to have this information. So we have to have A plus B plus C. And then Heron's formula itself is going to be the area. Okay, so we have the area is equal to the square root of S times S minus A times S minus B times S minus C. All right, so the first thing we're going to have to find out is how long each of the segments of these triangles are. And so I'm going to recommend that you just use the distance formula. So I'm going to say the distance of A, okay, and then the distance of B and the distance of C. Okay, and we can choose to make this, these are arbitrary choices. So I'm going to first find the distance between these two. So -7, that leaves us with -7 minus 1, which is -8 squared, right? Okay, then we have -5 minus 7, which is -12 squared, okay? And that gives us, when we add everything together, that should give us the square root of 208. Now, don't take time to simplify any of this stuff, just leave it like it is. Okay, the next thing we're going to do is take, maybe we'll take these two. We'll take the distance from here to here. Okay, so 1 minus 2 is -1. And that, if you square that, I'm going to put that down here because that's how I had done it in my original here. 1, and then we've got 7 minus -1, which is going to be 8. So that gives me 8 squared, and obviously this was squared as well. So that's going to give me square root of 65, I believe. Okay, I'll make this one green. And so then that leaves me with finding the segments from here to here. Okay, so -7 minus 2 is -9. Okay, so that's -9 squared plus, and then -5 minus -1, which is, I think, going to give me -4 squared, which would give me, let me think here, 81 plus 16. Yeah, so this is a square root of 97, I believe. Okay, so now I have my side lengths, right? So I can figure out what this is. So I have S equals, actually, let me change that. Let me change this color here so we keep everything organized. S equals 1/2, and so I have to add these three pieces together. So it's the square root of 208 plus the square root of 65 plus the square root of 97. Do you see how keeping these as the radicals makes the process a little bit easier? And yeah, then you don't have to try to write all these decimal numbers down and keep track of what's going on. So now we have S is equal to, and what I came up with is approximately 16.17. But I left that number in my calculator so I don't have to type that all in, and so there's no rounding errors. So because that S value, I'm going to use that 1, 2, 3, 4 times, right? So now I know that the area is equal to, and so you can enter S here, right, which is going to be, I'm writing down 16.17, but you're going to just leave it in your calculator. And then here we have 16.17 minus the A value, which is the square root of 208, right? Okay, parentheses. And I entered all of this into my calculator at once without too much trouble. And it came out really, really well. So I was happy about that. And the B value is the square root of 97, okay? And then we have the last one, 16.17 minus the square root, let's see, for C was the square root of 65, okay? And then obviously close that up. So if you multiply 1, 2, 3, those 4 things, and then take the square root of it, you should come out, I actually came out with a whole number. It came out exactly even, which shocked me completely when I got there, because I thought I didn't think it was going to be that nice. But I think it's because I left 16.17. I didn't actually round 16.17 until I was completely done. So I'm going to let you figure out what that is and go from there.